Hi everybody. In the last video we talked about the limits on rational functions as x goes to infinity or negative infinity. This time we're going to talk about limits on rational functions as x goes to a particular number. So let's look at our function g of x equals x plus 1 over x. If we were to graph y equals g of x on Desmos or our graphing calculators, we would notice there's an asymptote at y equals 1, and the graph looks something like this. There's comes in two halves, and it goes like that. And we can kind of see from the ends of the graph that the limit as x goes to infinity is 1, and over here the limit as x goes to negative infinity is also 1. But what happens at other places? So let's talk about the limit as x goes to 1 on g of x. Now, at x equals 1, the graph is continuous. We've got that value right there. So we can just, since the graph is continuous, we can just plug in the value in that. We've got, that's going to be 1 plus 1 over 1, which is 2. So if the graph is continuous, or the function is continuous at a particular value, we can actually plug in the value. But if we wanted to do, for example, the limit as x goes to 0 on g of x, we notice that there's an asymptote there at 0, because x can't be 0, or we'd get something undefined in there. So we have to look at things a little bit differently. I want you to notice on this particular graph, we can see from the graph that as x goes to 0 from the right, remember we use that little plus sign from the right, the limit as x goes to 0 in g of x is going to be infinity, and the limit as x goes to 0 from the left on g of x is going to be negative infinity. So the limit as x goes to 0 on g of x does not exist. We can also tell this a little bit numerically. If we think about this, x plus 1 divided by x, if x is getting close to 0 from the right, we're adding on really, really teeny tiny positive numbers, and a teeny tiny positive number plus 1 gets close is going to still be positive, and this is still going to be positive, and so we can kind of tell that it's going to go off toward positive infinity. If x approaches 0 from the left on x plus 1 over x, this guy is going to go to negatives, and this guy is going to go to positives because we're adding little bitty pieces plus 1, and so this is going to go toward negative infinity. So we can do a little bit of sign analysis on that as well. Let's take a look at another one. Let's look at h of x. Actually, we'll look at h of x in the next video.